Okay, so in exponentials, there are a couple of bases that are particularly special for us that are unique. So the first one is what we call a natural base. So there was a mathematician who started playing around with this 1 plus 1 over n to the n. So he started with n as 1. So he got 1 plus 1 over 1, which is 1. So 1 plus 1 is 2 to the first. So he got the number 2. Then he let n be 2. So he got 1 plus a half squared, okay, which is 2.25. And then he did 1 plus 1/3 cubed, and 1 plus 1/4 to the 4th, and 1 plus 1/5 to the 5th, and so on and so forth. And so as n got really, really big, what he realized is that he was getting this number, this 2.718281827. About the time you think this thing is going to repeat on itself, it doesn't. So it's kind of like pi. And so this number was then connected to this mathematician, and they gave it the notation e. So on a calculator, when you see a lowercase e, it is this number, this 2.718 number. Now, the mathematician, everything in my East Texan wants to name him Euler, but it is not. This is Euler, okay? So it's pronounced Euler, but they did reference it with this E, okay? So now, to see this being used, okay, in our context of stuff that we've been doing, we've got a gray wolf population in the Western Great Lakes, is modeled by the equation 1066 e to the 0.042x, where x is the years after 1978. Okay, now you've got to watch when they do stuff like this. Okay, so they want us to predict the area in 2012. Okay, so what we're going to do is I'm going to pull up my calculator. Okay, let me clear what I've got. Now, we'll talk a couple things. Now, first off, if we're going to do 2012, then we need to do 2012 minus 1978. Okay, so that we know what x is. So in this case, x is going to be 34. Okay, now, if we are doing this on a TI-84, okay, with this particular calculator, again, it's going to be very, very similar to what we saw done in the first time. So we're going to do 1066. Now, we have an e to the x button. It's over here in blue, okay? It's in blue, which means I'm going to press the blue button, and then this button, it's going to bring in e. Now, again, this particular version does go ahead and put my stuff up in the exponent. So now I can put my 0.042, and then I'm going to do times x, what my x was, which is 34. Okay, so I get 4445.59. Now, because we're talking about animals, you cannot have part of an animal. So you can go either way on the rounding here. Some will say that that 0.59 is not an entire wolf, so we're only going to count the 4,445 wolves that we have, and so they would just take off all the decimal. Some will say that if you have any part of a wolf, then it will automatically go up, so you would have 4,446. Either response would be acceptable. Now, let's talk about what to do with this if you don't have where it auto does. Now, if you're still working on a TI-83 or 84 and it just doesn't put it up into the exponent, okay, you're still going to do that E thing here, okay, but it's going to show a little wedge. At that point in time, you do parentheses, 0.042 times 34. And you close that set of parentheses. Again, there would be a little wedge shape here, and this would still be written all where it's at. You get some answer. Now, if you were working with a regular non-graphic calculator, you're going to start by doing your 0.042 times 34. Excuse me. Okay, and we get this 1.428. Now, this e to the x button, okay? So you would then do your e to the x, and you would need to put that 1.428 number in there and get a number, okay? You should get 4.17. Then, same as we saw kind of in that very first video for this section, times the 1066, okay? So you're actually kind of working in order of operations type thing. Notice we're still coming up with the same answer. Now, again, depending upon what your calculator does or how it is set up, will dictate which of the versions that you are doing with that, okay? So now, going back to our PowerPoint, okay? Now, one of the other applications that we see done, okay, with this is what's called compound interest, okay? So, compound interest, this is savings accounts, this is car notes, on a basic level, car notes, house loans, things like that, where you are getting interest usually more than one time a year, but it could be done yearly, and we're processing through. So the formula is A equals P parentheses 1 plus R over N raised to the NT. Notice the N is used twice there, okay? A is the amount that's in your account. So if we're talking about a savings account, this is the amount of money that would be in your savings account after however long. P is the principal, or the amount that you put in. Now, when we're doing these, especially if we're talking about savings accounts, we're talking about a one-time drop it in, sit it, let it go. Okay, we're not talking about constantly putting stuff in or taking things out. Those are other formulas, but on a basic level. Okay, R is your rate. This does need to be done in decimal. Oftentimes they are given to you in percentages. You need to convert that into a decimal. N is the number of compoundings in a year. So if they say things like quarterly, there are 4 quarters in a year, okay? Semi-annually means twice a year, so that would be 2. Monthly would be 12, okay? And then T is time, usually in years. You do usually have those match up since we're doing compoundings in a year. Time is also in years. Now, if they make a statement about continuous interest, and that would be stated in it, then we will utilize the formula A equals PE to the RT. If you look back up there, you can kind of see hidden around there, we've got that 1 plus over N raised to the N. That was that Euler's thing that showed up, okay? So now what we're going to do is they want us to compare investments. So they ask, which is better? We've got a lump sum of $10,000, so I'm going to write these down. That means P is 10,000. We have a rate of 8%, and they're doing 5 years, so T is going to be 5, and then we're doing quarterly compounding, so that is N is 4. Now, for the other one, for B, we're still doing our $10,000. Our rate is 7.8%. Time is still 5, but it says we're doing continuous interest. Okay, so let me pull this up on our board so that you can see what I've got here. Okay. Okay, now, first off, when we're doing this interest, now I wrote it as the percentage. Keep in mind that this is going to need to bump out. Okay, so 8, and we're going to go bump, bump. So that means I've got an inch. My R is going to be 0.08 for this one. Over here, bump, bump. I'm going to have that this is 0.078. Okay, when we get ready to this one. Now, this is your traditional one. So this is going to be A equals P 1 plus R over N to the NT. So let's talk about putting all this in. So it's going to be 10,000, 1 plus 0.8. Quarterly was 4, and I'm just going to do parentheses up here, times 5. Now I'm going to clean this up a little bit before I push it to a calculator. Okay, so I'm still going to have my 10,000 up here on the front. 0.08 divided by 4 is going to be 0.02, so this is going to be 1.02. 4 times 5 is 20. So I'm going to pull my calculator, and I'm going to let the calculator do some work for me. Okay, so we've got 10,000 parentheses 1.02. I'm going to use my little wedge 20, and I get that this is $14,859.47. We're dealing with money, so it would be logical for us to go 2 decimal places. Okay, so there's where we got that one. Now, let's talk about the setup for the other one. This one they said was continuous. So that's going to be P equals, or A equals PE to the RT. So again, we've got the 10,000 E, that was 0.078 times 5. Okay, again, I'm going to do a little bit of cleanup here. Okay, 0.078 times 5 is 0.39. Okay, so now I'm going to pull that up on my calculator. So I'm going to do 10,000. I'm going to do my E and 0.39. I'm going to press enter. So I get that this one is $14,769.81. We are going to round appropriately for that one. So at this point in time, 5-year mark, we would say that option 1 or option A was the better investment, okay, by about $100, a little under $100. Now, that is not to say that investment 1 or investment A is always going to be the better investment, okay? If we were to calculate this at 10 years, it might be the other one. I don't know. We would have to just process it and see which one is better.